come up with a formula for the area of the shaded purple bit here. So somehow come up with a formula for it. All that you're given is that this distance here is x. Okay, so this distance here is x. That's all that you're given. So within this square, if this is x, then this must also be x. Okay, but okay, you're not given this. You're just given this length here. Because it's a square, then you know the vertical part must be x anyway. So here you've got four identical smaller circles inside a big square. Somehow come up with a formula for the purple shaded bit. Okay, so press pause and have a go. Okay, so the area of the big bit is really square. The area of the square. Take away 4 circles. Okay, so yeah, if you want to know the area of the shaded bit, it would be square, take away 4 circles. Well, let's forget about the plural for the time being. So here, hang on, let me think. Oh yeah, the area of the square would be x here times x down here, so it would be x squared. Okay. Take away. Well, what's the area of the small circle here? Well, basically, you need to know the radius if you want to know the area of something. If you want to know the area of a circle, you need to know the radius. So what is this distance here? Well, if you think about it, the whole square here it's a distance of x. Okay, but then half of the square here. So from here to here is really the same as from here to here. So that would be a half x. Well, let's view it as this, x over 2. Okay. So from here to here is x over 2. But then so basically this is our circle here. But then we only need half of that. So we need half of this basically. Okay. So let's see, half of x over 2. If you know what I mean. Let me start down here. Okay. So from here to here is x. Okay. We want to know the radius of this circle here. So from here to here is half of an x, isn't it? From here to here is x over 2. Okay. So from here to here is x over 2, but we need half of that. So half of that thing, half of this thing is really we've got x over 2, and then we need half of it. So you can think of it as like this. So basically, top times top, it would be x. Bottom times bottom, it would be x over 4. So what I'm saying is that if this is x here, half of it would be x over 2, and then half of it again would be x over 4. So the radius here is x over 4. Okay, and that exists in a bubble. Okay, let's go back to this thing here. So the circle, so the radius of this circle is x over 4. Okay, so now let's see 4 lots of this circle. So pi x over 4, and then we've got to square it. Okay, so this is our square. Now this is our small circle. Okay, pi r squared. But the radius is pi over 4. So we're putting the radius into here. So it becomes this. Okay. Let's tidy this up. Let's work out this bit here. This bit here is quite complicated. So find a blank space somewhere. Let's see, x over 4 squared means times by itself. Okay, so now it would be top times top, which is x squared, and then bottom times bottom, which is 16. Okay, so let's see. So this bit here is this here. Okay, so this will become whether x squared take away 4 4 pi, and then and remember this bit here is actually x squared over 16. Okay, and now remember it's basically this thing here multiplying a fraction. So when you multiply a fraction, it gets multiplied to the top. So it becomes this, x squared take away 4 pi x squared over 16. Okay, because anytime you multiply a fraction, it gets multiplied to the top. So remember this, a over b times c, that becomes ac over b. It gets multiplied to the top. Okay, so now and now let's see, we can divide. Just look at this fraction only. Okay, we can divide top and bottom here by 4 because I know that 4 exists up here and 4 exists within the 16. Okay, so this will become this. Divide. So just this bit here, divide by 4, it will become pi x squared. And the bottom part, 16 divided by 4 is 4. Okay, so basically this fraction here, this fraction here is the same as this fraction here, but the bottom one looks a lot simpler, neater. Okay, so now hang on. So now we've got one whole thing taking away a fraction. So let's turn this thing here into a fraction. It's just the way we cheat. Okay, so we're going to cheat and turn this into a fraction, and then take away pi x squared over 4. Now times top and bottom here by 4, because in order for us to merge the two fractions together, we need the two denominators to be the same. So just this one only, multiply top and bottom by 4. So this will become 4x squared over 4. Take away pi x squared over 4. Okay, now the two denominators are the same. We can merge. We can merge the two. So now it becomes this 4x squared take away pi x squared. Okay, and now have just look at the upper part, this bit here. See if we can merge these two. Now this is like these two are different entities. Remember when I said x is one entity, x squared is another entity, x to the power 3 is another entity. So if I give you 2x squared and then ask you to add it to 4x to the power 3, you can't do it because this is a different entity from this. It's like me asking you 2 elephants plus 4 giraffes. They're two different things, so you can't add the two together. Look at this here. This is different from this, so you can't add the two. You can't add the two, so you just have to leave it as it is. So it will be this pi x squared over 4. Yeah. So here just leave it as this. This would be our final answer. So the area of this shape here, or the purple shaded bits here, or the shape, basically the area of that is this. Okay.